Think about this for a second. You pull out your phone, open Google Maps, and almost instantly, that little blue dot appears right where you are, sometimes within a few feet. But how does your phone know your exact location? It is not guessing, and it is definitely not magic. It is using one of the most advanced systems humans have ever built, a network that literally listens to signals from space. Today, let us break down how GPS truly works and how it knows exactly where you are. In the simplest way possible, GPS stands for Global Positioning System. It is not something stored inside your phone. It is a global network of satellites orbiting Earth about 12,000 miles above us. There are usually around 30 active satellites, and each one is constantly sending signals toward Earth. These signals contain two key pieces of information: the exact time the signal left the satellite and the satellite's position in space at that moment. Your phone or any GPS receiver acts like a listener. It picks up these signals from multiple satellites and uses them to figure out one thing: your exact spot on the planet. Here is how it works in simple terms. Imagine you are standing somewhere, and you hear a sound from one tower that is exactly 1 mile away. That tells you that you are 1 mile from that tower, but not exactly where, because you could be anywhere in a circle around it. Now, if you hear another tower that is 2 miles away, those two circles overlap in 2 possible points. Add a third tower, and those 3 circles intersect at just 1 point: your location. That is exactly how GPS works, except instead of towers, it uses satellites floating far above Earth. Your phone measures how long each satellite signal takes to reach it. Because these signals travel at the speed of light, even a tiny difference in time, just a few billionths of a second, can change the calculated distance by hundreds of feet. When your phone receives signals from at least 4 satellites, it can solve a 3D puzzle: your latitude, longitude, and altitude. It even uses those signals to correct its own internal clock, which is not nearly as accurate as the atomic clocks on the satellites. Time is the true secret behind GPS. Each satellite carries an atomic clock that is accurate to within a billionth of a second. Your phone's clock, by comparison, is much less precise, but by analyzing multiple signals, it can synchronize itself to those atomic clocks. If the timing were off by just 1,000th of a second, your location could be wrong by hundreds of miles. That is why precision timing is the foundation of the entire GPS system. When you use GPS, your phone often combines data from other navigation systems too, like Europe's Galileo, Russia's GLONASS, or Japan's QZSS, to increase accuracy. It also uses nearby Wi-Fi networks and cell towers to refine your position when satellite signals are weak, such as in cities, tunnels, or indoors. That is why your location still shows up even when the sky is cloudy or you are inside a building. Of course, GPS is not perfect. Mountains, tall buildings, and even solar activity can interfere with the signals, but powerful algorithms inside your phone constantly correct those small errors, so you get a nearly perfect reading. So the next time you are watching that little blue dot move as you walk down the street, remember what is happening behind the scenes. Your phone is communicating with satellites flying thousands of miles above Earth, calculating distances and adjusting for time differences, all so it can tell you where you are within a few meters. GPS is one of those invisible technologies we use every day without a second thought. It is built on physics, math, and decades of engineering, yet it quietly guides billions of people every single day. The next time you get directions, track a package, or share your location with a friend, you will know the invisible science working behind the scenes. If you learned something new today, tap like, hit subscribe, and share this video with someone who has ever wondered how their phone actually knows where they are. Because the next time you see that little blue dot, you will not just know where you are, you will understand how you know.